Hi everyone, welcome to the online classes. Today in this video we are going to discuss the concepts of a basic postulates of a Boolean algebra, and in the last video we are discussed about the logical gates, where the basic gates we know that are AND gate, OR gate and the NAND gate, which is called as a inverter or a NOT gate, and we are discussed that about operations of a gates and the basic symbols for them and how they works, what are the operations we can apply on them, and the truth table for the individual logic gates based on the number of inputs. And in this class we are going to discuss about basic postulates of a Boolean algebra, where I just in the starting of this class only I have told that Boolean algebra is a system of mathematics and consists of fundamental laws. These fundamental laws are used to build a workable, cohesive framework upon which are based the theorems of Boolean algebra. And these fundamental laws which are used in the evaluation of a Boolean expressions or logical expressions are known as a basic postulates of Boolean algebra, and these postulates are as below. Fundamental laws of a Boolean algebra are called the postulates of a Boolean algebra. Fundamental laws which are used in the expression, evaluating the expressions, are called as a Boolean algebra. Fundamental laws of Boolean algebra are also called as a postulates of Boolean algebra. And now Boolean postulates are mainly four types. First one is, if x is not equal to 0, then x must be a 1. I have told that in the very first class only that Boolean algebra, overall the Boolean algebra works on only the binary number system. That binary number systems consist of 0 and 1. When it is if x is not equal to 0 in the sense, it must be a 1. When x is not equal to 1 in the sense, it is a 0. Either x, the variable x is there in the sense, in a Boolean algebra x is there in the sense, it must be consists of either the value of 0 or else of 1. Here the very first Boolean postulate is that one, if x is not equal to 0 and then x is equal to 1, and if x is not equal to 1 in the sense, it must be 0. That is the first fundamental law or else a postulate. And we have OR relations. There is no much information is not needed, I hope so, because you know the OR operation and OR gate also. Same explanation is required here. For OR relations, when the 0 is ORing with the 0, we will get a 0, and the basic gate for that one, this one is a basic gate. There is no necessity to write a OR, just we can write the symbol OR with the two inputs as a zeros, output will be 0. Like that, 0 and 1 combination will give you a 1, 1 and 0 combination will give you a 1, 1 and 1 combination will give you 1. This is a OR relations. This is a second postulate of a Boolean algebra. Third one is a AND relation. This is also no need much explanation. You know the AND operation, where these 0 0 and 0 1 1 0 1 1 represents you the xy values, represents these are the possible symbols of a AND gate. Now next one is a complement rules, where complement rules or also NOT gate consists of only two variables. One variable. It contains only a one input and a one output, we know that. And one input in the sense, the possible inputs are a 2 to the power of 1, two possible inputs, either 0 and 1. When you complement it, and in the sense when you apply the NOT gate, it will give you another numbers 0 into 1, 1 into 0. That is the complement rules. This is the fourth basic postulate of a Boolean algebra. These four are the basic postulates of Boolean algebra. First one is, if x is not equal to 0, then x equal to 1, and if x is not equal to 1, then x is equal to 0. And the OR relation, second one, AND relations, third one, complement rules is a fourth one. These four are the basic postulates of a Boolean algebra. We have to remember always these are the very important things and the basic things these are, and these are the, here we have the basic theorems of a Boolean algebra. Just now we have discussed about the basic postulates, and now we are going to discuss the basic theorems of a Boolean algebra. Basic theorems of a Boolean algebra, where basic theorems we have a different types like properties of 0, properties of a 1, idempotence law, involution, complementarity law, commutative, associative law, distributive and absorption law, where these individual laws contains a one or more postulates. These laws, individual laws, contains one or more individual postulates, where these postulates are also basic laws are used to simplify the Boolean expressions in a different way. These are used to simplify the Boolean expressions, where one of the method we have learnt in the last classes, that is to simplify the Boolean algebra or evaluation of a Boolean algebra, is a truth table. Truth table is a one method, and postulates, using the postulates are a basic class, we are able to simplify the Boolean expressions. This is the another way, simplifying the Boolean expressions using the basic theorems and postulates. That's why these are all the important, and with the proofs we have mentioned the basic theorems of Boolean algebra. Main types are properties of 0, properties of 1, idempotence, involution, complementarity, commutative, associative, distributive and absorption law. These are the main laws, and under the individual laws we can get a one or more postulates. Let us see one by one. First one is a properties of a 0, where properties of a 0 defines you two postulates. One is the 0 oring x is equal to 0 x. 0, when oring operation between a 0 and x is equal to gives you the results x, where this x is a logical variable and gives you again a x. Let us see with the proof. Possible values for a x are 0 and 1. In the Boolean algebra we have only a variable value will be 2, either a 1 or else a 0. Possible values for x is 0 and 1. When you put x is equal to 0, 0 or 0 is equal to 0, you will get here 0, and when you put x is equal to 1, just observe the neatly observe here. Just observe it here thoroughly. When you put a x is equal to 0, result will be 0 again. When you put a x is equal to 1, result is again a 1. So here properties of 0 tells you the first postulate, 0 plus x is equal to 0. And the second postulate of a properties of 0 is 0 and this dot symbol simplifies, just tells you the AND operation, 0 and x is equal to 0. Let us see by the proof. Possible values for a x is 0 and 1. When you put a x is equal to 0, it results you 0 and 0 is equal to 0. This is a basic thing, you know, I hope so, by the AND operation. And when you put x is equal to 1, 0 and 1 is equal to again 0 you will get here, 0 you will get. So this is the proof for second postulates of properties of 0. Likewise, properties of a 0, that is postulate 1 is a 0 plus 0 or x is equal to x, again you will get 0 and x is equal to 0 you will get. Likewise, properties of 1 are there. When you apply OR operation with a 1 using the one of the variable, that is called a x, you will again get a 1. Here is a proof is there. Possible values of a x are 0 and 1. When you put a x is equal to 0, 1 plus 0 is 1 plus 1 or 0 is equal to 1. When you put a x is equal to 1, 1 or 1 again gives you the 1. Likewise 1